Good morning. Um, Let me just see. I am so late today. It seems like one day I'm able to wake up at for 5 o'clock streams. I have to wake up at 4:45. One day I'm able to wake up. The next day I am exhausted and I have to figure out how to sort of go to bed on time so that I'm not so tired and then I can wake up because it really does help doing this earlier and waking up a little earlier. Anyways, I have really a half an hour or maybe even less, maybe 20 minutes to finish this. So I'm going to share the screen and begin this. And today's passage is philosophy, is a subject on philosophy. And it's got 5 questions. It's titled Karl Popper. Karl Popper, who died in 1994, was widely regarded as England's greatest philosopher of science since Bertrand Russell, indeed a philosopher of worldwide eminence. But today his followers among philosophers of science are a diminishing minority, convinced that Popper's vast reputation is enormously inflated. Popper's reputation was based mainly on his persistent but misguided efforts to restate common sense views in a novel language that is rapidly becoming out of fashion. Popper's best known claim is that science does not proceed by induction, that is, by finding confirming instances of a theory or conjecture, but rather by falsifying bold, risky theories. Confirmation, he argued, is slow and never certain. By contrast, a falsification can be sudden and definitive. Moreover, it lies at the heart of the scientific method. A familiar example of falsification concerns the assertion that all crows are black. Every find of another black crow obviously confirms the theory, but there is always a possibility that a non-black crow will turn up. If one does, the conjecture is instantly discredited. David Hume's famous question was, how can induction be justified? It can't be, said Popper, because there is no such thing as induction. However, there are many objections to this startling claim. One is that falsifications are much rarer in science than searches for confirming instances. Astronomers look for signs on Mars. They do not think they are making efforts to falsify the conjecture that Mars never had water. Falsifications can be as fuzzy and elusive as confirmations. Einstein's first cosmological model was a universe as static and unchanging as Aristotle's. Unfortunately, the gravity of suns would make such a universe unstable. It would collapse. To prevent this, Einstein, out of thin air, proposed the bold conjecture that the universe, on its pre-atomic level, harbored a mysterious, undetected repulsive force he called the cosmological constant. When it was discovered that the universe is expanding, Einstein considered his conjecture falsified. Indeed, he called it the greatest blunder of my life. Today, his conjecture is back in favor as a way of explaining why the universe seems to be expanding faster than it should. Astronomers are not trying to falsify, they are looking for confirmations. That is, they are using induction. Falsification may be based on faulty observation. A man who claims he saw a white crow could be mistaken or even lying. As long as observation of black crows continues, it can be taken in two ways, as confirmations of all crows are black, or disconfirmations of some crows are not black. Popper recognized but dismissed as unimportant that every falsification of the conjecture is simultaneously a confirmation of an opposite conjecture. That when you prove something false, you prove that the negative of that thing is true. If you disprove the statement, all crows are black, you have proved the statement, not all crows are black. To scientists and philosophers, science operates mainly by induction, which is confirmation, and also and less often by disconfirmation, falsification. Its language is almost always one of induction. Astronomers are now finding compelling evidence that smaller and smaller planets orbit distant suns. Surely this is inductive evidence that there may be Earth-sized planets out there. Why bother to say as each new and smaller planet is discovered, that it tends to falsify the conjecture that there are no small planets beyond our solar system. Scientists seldom attempt to falsify. They're inductivists who seek positive confirmations. The original title of the article was A Skeptical Look at Karl Popper, and it was written by Martin Gardner. So question number 1 is, the main thesis of this passage is closest to which of the following statements? Science falsifies only those conjectures that are incorrect. Science is never able to truly prove things inductively. Science works by systematically confirming conjectures. Science should use disconfirmation to prove its claims. Well, science uses induction mainly, and induction is based on confirmation of conjectures. So science works by systematically confirming conjectures seems like the most appropriate. And that is the correct answer. This is correct because it is the closest to the main idea. Next question. One can justifiably infer from the last paragraph that if a scientist were asked to explain their findings in terms of falsification, that scientist would find falsifying as difficult to phrase as confirming, find the task cumbersome, but would be able to do it, be convinced of the value of falsification, be unfamiliar with the concept of falsification. Well, it would be more cumbersome. They would find the task more cumbersome. They should be able to do it, but I think being familiar with the concept of falsification is more likely because they are used to confirming only. But let's go over the last paragraph just one more time. To scientists and philosophers, science operates mainly by induction, confirmation, and less often. So it does go by falsification as well, this confirmation. Its language is almost always one of induction. Astronomers are now finding compelling evidence that smaller and smaller planets orbit distant suns. Surely this is inductive evidence that there may be many Earth-sized planets out there. Why bother to say, as each new and smaller planet is discovered, that it tends to falsify the conjecture that there are no small planets beyond our solar system? Scientists seldom attempt to falsify. They are inductivists who seek positive confirmations. Okay, so find the task cumbersome. That seems to be the best option because they're familiar with it. They're not unfamiliar with it. And it doesn't say some of them would be unfamiliar with it, right? Because that's what the paragraph implies. So I think they would find the task cumbersome but would be able to do it. And that is the correct answer. This is correct because the last paragraph contains an example of a finding that is rephrased from one that confirms to one that falsifies. The phrasing is awkward and is implied to not clearly be worth doing, but the last paragraph demonstrates that it is clearly possible. And let's see why D is not the correct answer. The last paragraph does not suggest scientists would be unfamiliar with the concept of falsification. The paragraph states that scientists falsify sometimes. And the example of scientists discussing Earth-sized planets implies that a scientist would be able to describe their findings in terms of falsification. Question number 3, which of the following is most like induction and as it is described in the passage? Okay, so I usually find these analogies difficult to do. Let's see. Comparing your car's gas mileage to that of another car, I would say no, because it's not different enough. No, okay. Which of the following is most like induction? Induction is a process of confirming the conjecture. And right, it says right here. Popper's best known claim is that science does not proceed by induction. And then they gave a definition of what induction is. That is by finding, confirming instances of theory or conjecture. Okay. So, rewatching a movie you hate, but that everyone likes. Weighing oneself weekly to determine if the diet is working. Finding a restaurant that serves the food you are craving. I think the last one is more because you're looking for confirmation of what the theory that you've put out. Finding a restaurant that serves the food you are craving. Oh, not correct. Because this choice might be tempting, but it lacks the aspect of confirmation that is a key aspect of induction. Okay. C is more correct, which is weighing oneself weekly to determine if a diet is working. Weighing oneself weekly to, okay, this is confirming. This is correct because the weighing is done to confirm that the diet is working, just as induction is defined as trying to confirm as an instance of a theory or conjecture in paragraph 1. Oh, Siri just, that was funny. Okay. Question number 4. In paragraph 2, the author suggests that Karl Popper believes an inductive claim is confirmed only if it is a useful tool for testing hypotheses. Oh, 1 second. Oops. Okay, let's go back. Okay. All right, so in paragraph 2, the author suggests that Karl Popper believes an inductive claim is confirmed only if it is a useful tool for testing hypotheses. That claim cannot be contradicted. It can simplify complex realities. It is based on logical assertion. Um, inductive claim. So this is what he said about the inductive claim. He's talking about falsification here, but he does not believe in induction. How can induction be justified? It can't be, because there's no such thing as justification. It can simplify complex. It is useful for, no, it doesn't. It's confirmed only. Okay. However, there are many objections to his claim. One thing is falsification. Confirmation, he argued, is slow and never certain. Okay. This isn't Karl. This paragraph, the last paragraph, isn't what Karl Popper believes. Okay, so here is where I think the first two paragraphs where he mostly his view. Oh, okay. There you go. Right here too, when they're talking about crows. Popper recognized but dismissed as unimportant that every falsification of a conjecture is simultaneously a confirmation of an opposite conjecture. That is, when you prove something false, you prove that the negative of that thing is true. If you disapprove the statement all crows are black, you have proved that not all crows are black. Okay, so you've disapproved. So in paragraph 2, oh, okay. A familiar example of falsification concerns the assertion that all crows are black. Every find of another black crow obviously confirms the theory, but there is always a possibility that a non-black crow will turn up. If one does, the conjecture is instantly discredited. David Hume's famous question was, how can induction be justified? It can't be, said Popper, because there is no such thing as induction. So the author suggests that Karl Popper believes an inductive claim is confirmed only if it is a useful tool for testing hypotheses. That claim cannot be contradicted. Okay, so this seems like it. And that is the correct answer. This is correct because for Karl Popper to say that there is no such thing as induction in paragraph 2, because finding a confirming instance does not preclude the possibility of some contradicting case. Not finding a non-black crow does not mean that one will not find one eventually. The author must be suggesting that for Popper, for induction to be successful, that must mean that no contradicting case is possible. Okay. Last question. The author cites the search of water on Mars to assert that, and then right here it says, right, however, there are many objections to this startling claim. One is that falsification are much rarer in science than searches for confirming instances. Astronomers look for signs of water on Mars. They do not think they are making efforts to falsify the conjecture that Mars never had water. Falsifications can be fuzzy and elusive as confirmations. Okay, so falsification is, the author cites the search for water on Mars to assert that falsification is not in keeping With scientific practice, falsifying a conjecture is difficult to. Einstein's first cosmological model was accurate. Even someone as accomplished that. Well, no, falsification is not keeping with scientific practice in the usual way. And that is the correct answer. This is correct because the passage cites search for water on Mars in paragraph 3 to help reinforce the main point that science progresses through induction and not through falsification. And that's our passage. If you want, you can also watch the passage analysis. One of these days, I'd probably like to do that as well. But until tomorrow, that'll be it. Thank you for watching.